Well, hello and welcome back. I just wanted to make another quick video about about something that I saw in the news this morning, actually, which is an article on, whether it's time for programmers to stop being so lazy and to write more efficient code. And the whole basis of this article was that we are apparently approaching the limits of Moore's law again. So we're approaching the point where the pace of innovation in terms of processing power is declining. So we can't any longer continue, or not for very much longer, the article argued, continue to assume that processing power will continue to increase. And the argument was that, that because programmers, because people who, develop software, like us, have always been able to assume that, there'll always be more processing power, next month or next year or whatever, then it's become unnecessary for programmers to focus on writing efficient code and to think about how they're optimizing their use of the available computing resources. And I mean, it's an interesting argument, but it's an old argument. This has come up before, and I think this argument actually comes up cyclically, because there's always a point sort of where we start to reach what we think are the limits of Moore's law, and like everyone starts worrying of like, ooh, okay, we're going to stop. Soon we won't be able to increase the power of computers, any further. And then there's always some kind of innovation that happens, and we get through that, and then there's another period of development and increasing power. Originally, the increasing CPU power was always about clock speed, pushing to ever faster clock speeds, and and then the move from 8-bit to 16-bit to 32-bit and now to 64-bit processors and that kind of thing, and running at faster and faster clock speeds all the time. And then eventually we started to hit the limits of what was physically possible in terms of clock speed, because obviously physics eventually will get in the way with that sort of thing, right? You can't just increase your clock speed indefinitely. And then we moved to multi-core, so rather than having just a single core running at, X gigahertz, you now have multiple cores clocked at that speed, and the idea being that you can, distribute your processing across the different cores, and therefore continue with the process of development. And that's a good point. And then again, because there are limits, I suppose, on how many cores you can see, proper traditional CPU cores you can fit into a reasonable size. Then there was the push to GPU processing and offloading calculations and stuff onto the GPU, using compute shaders with OpenGL or whatever. So we've been continuing with this, and I think this is partly driven. It's interesting to think about sort of what's the sort of demand, what is it that drives this kind of innovation. And arguably, and I think the article argued the same thing, that it really is the software, because people want to do more and more things with their computers, so there is a continuous demand for innovation in terms of processing power. And this sort of creates this cycle that the software creates the demand for more power becomes available, and therefore there is less incentive for software developers to work so efficiently. And like I say, it's an old argument, and it's one I've definitely heard before. And it does really sort of open up the question, are programmers just getting lazier? I actually don't think that's really true. But if we think about just the argument of the article on its own, and I can think back to one really good example, actually, of how programming was different in the past. So back in, I think, 1990 it was, someone created a port of the game SimCity. If you haven't played it, it's a city building game. It's very good, but look it up on Wikipedia if you want to know what it's about. But someone created a port of that game that could run on the BBC Model B microcomputer, which was not, in 1990, it wasn't exactly cutting edge, but it only had 32 kilobytes of RAM. And I mean, that's the total, not 32 kilobytes that was available to programs to run, but 32 kilobytes in total, out of which it also had to have RAM for the display, it had to have RAM for the operating system, RAM for a variety of other things that it had to do internally. And that left, I think, if I remember correctly, about 25 kilobytes of RAM that was available for programs to actually run in. And to make something as complicated as SimCity that could run in that just 25 kilobytes of RAM is an incredible achievement, really not to be underestimated. And I actually have played this game on a BBC microcomputer, and I can remember one of the things that they had to do, so at the end of the year in the game, it had to calculate how much of the regions the player had defined were connected to the power grid, and there just wasn't enough RAM. And I think actually at around the time, around about 1990, I remember reading about this in a magazine article, and there just wasn't enough RAM. After squeezing out every individual byte, every last possible byte of RAM, there was just no way to make this work, to be able to calculate the power grid connectivity. And so what they had to do was use the display RAM to do it. And I remember playing the game, and when it came to the point in the game where it would do this calculation, the display would fill up with all this seemingly just random noise while it did this calculation, and then it would go back to the normal display. And I think that's the kind of thing that this article was talking about, that's the kind of thing programmers had to do in the past just to be able to get their code to run. Whereas now, we very much take the hardware for granted. There's very little sort of... It's rare that you really need to think about it. You really need to think like, ooh, do I have enough RAM to do this? Or, is there enough processing power available to do this in a reasonable time? In my day job, I do sometimes run into those questions. I regularly work with very large volumetric data sets and have to apply image processing algorithms and things to this data. And, I work on a machine that has only 8 gigabytes of RAM. Only 8 gigabytes of RAM. It seems funny to say that, to be honest, but it seems such a lot. But there are situations where it isn't enough. And I do find that occasionally I have to think about these problems and think about like, oh, hang on, how can I do this more efficiently? I need to make sure I'm not duplicating variables, or where I don't need to. If you create multiple classes in your code, that can be an issue. You need to think about how you're copying them around so you're not duplicating them, all that kind of thing. And I do find I still need to think about it, and I have occasionally knocked together an algorithm quite quickly to run it, only to find that even on my 8-core in CPU, it would take about 3 weeks to run. And then that calls for really going back to the drawing board and thinking about what I'm doing and how can I do this more efficiently. So it does still happen, but my case is that's a very special case, right? That's really not the case for software in general. And I think that the point that the article I read missed was that the arena for innovation in software development has moved on. So in the past, writing software was always this constant battle really against the limitations of the hardware. To get the hardware to do what you wanted to do was really hard, and you had to optimize your code as much as possible just to get it to work, just to get the hardware to do what it was you wanted to do. Now we don't have to do that. I think the innovation in software development is now in other areas, and now we innovate in things like in terms of making a code reusable. We innovate in terms of documented code. We innovate in terms of writing code that is more readable and understandable by other people. Code that another developer can pick up at a later time and almost immediately get started with what they're doing. I mean, as programmers, speaking for myself, not always very good at doing that, but I think this is really where innovation is now, and innovation in terms of processes and working in teams and this kind of thing. That's the current frontier of innovation really in software development. And so I think the increasing availability of hardware has changed how we innovate in terms of software, and I think that's a really good thing, to be honest. that would be my argument. I think it's a really good thing that the hardware has progressed to the point that whereas software developers, we don't really need to think about it so much anymore. And it means that we're free to focus on those other things, that I've just mentioned. And I can only think that that's a positive. And so the article kind of made it sound like this was a big problem, and how programmers would have to stop being so lazy. And it didn't actually explicitly use the word, lazy, but the implication was really there. It's like, ooh, programmers have got all lazy and software has become all fat and bloated and, whatever. And there was certainly a phase, I think, where that really did sort of start to happen a lot. But the problem with writing really bloated, fat code is that it's very difficult to make it secure, and it's very difficult to make it stable. So I think that has naturally kind of that problem has just sort of naturally become solved. The incentive was there just to avoid writing bloated code, because not only is it inefficient, it fails on all the other points that I've mentioned. It's not easy to read. It's very difficult to pass to other people. It's not easy to reuse it. It's not just about the efficiency of running the code anymore. It's about the efficiency of the whole process that surrounds software development. And to be honest, I think that whole process really leads to the development of, it incentivizes the development of efficient code. I would argue that if you're writing code that's clean, neat and tidy, easy to read, follows a really logical process to get the job done, then that code is probably fairly optimal already, and like I say, I just think it's a good thing that it's no longer necessary to worry about every last byte of RAM or every last cycle on the CPU. I think this is all a good and positive thing. As to whether the decline in the pace of innovation in hardware, I'm not strictly sure that's true. I haven't looked into the figures myself. It's like a supply and demand situation as I see it. So I think sort of hardware innovation tends to plateau at the point that there's no longer that push from software, no longer that push from people requiring more and more power. But that push never goes away. There's always something new. So at the moment, if I think about my laptop, it's powerful enough to do everything that I want to do. But that's everything that I want to do today. It's not necessarily the case, of course, for everything I want to do tomorrow or the day after or whatever. And I think there are certain sort of things that come up that, just as an example, in the sort of older days of computing, no one would ever have imagined people would be editing high definition or 4K video on a desktop computer in their home, or even a laptop at home. And yet now that's something we really take for granted. So that, I think, is a good example of how the use case of computers has changed, and that has really helped to push and to drive the development of the hardware in order to support that. I think the next big development in terms of use cases is AI and machine learning, and I think that the constant drive, the continuing drive into that area, and the push of those sorts of technologies into ever more domestic situations is going to be the next thing that probably pushes hardware forward and keeps that cycle going. I am less pessimistic, perhaps, than the author of this article was. So I don't think we're going to necessarily reach a plateau in terms of available hardware. I think the developments will still continue to come. I started this video really with the question, have programmers become more lazy as hardware has developed and they don't need to worry about it so much? And I think the answer is no. I don't think we have. I think instead what's happened is we've moved the arena of innovation away from one where we are simply struggling to get the hardware to do what we want, to one where we have the hardware to comfortably do what we want, and now we just want to make our code more interoperable, more reusable, more efficient processes for creating the code. And I think that's what's happened. It's just been a shift in where we're innovating rather than programmers actually becoming lazier. That would be my view on it. I mean, look, I'd love to hear your thoughts on this. If if you have any thoughts or comments, let me know in the comments below. As always, if you've liked this video, please remember to hit that like button, and please remember to subscribe to my channel so you don't have to miss any future videos. Thank you very much for watching. It's been a pleasure. Bye.